Hello guys, welcome to this channel. This is G Solutions. This channel finds solutions for your needs. Today, we will solve a problem involving alternating current sources expressed as a function of time. States here that an EMF E sub 100 sine 2 pi 50 t minus 75 degrees in series with an EMF E sub 2, which is equals to 120 sine 2 pi 50 t minus 105 degree. So what is the resultant EMF or the E sub 3? For letter B question, the angle between E sub 1 and E sub 3. For letter C, what is the RMS of E sub 3 or the resultant EMF? So for letter A, we just simply solve for the E sub 1 added to E sub 2. So we write here E sub 3 is equals to E sub 1 plus E sub 2. Okay? So we have here a value for E sub 1 and E sub 2. So we just substitute that one, and for E sub 1 we have 100 sine 2 pi 50 t minus 75 degree plus E sub 2 is 120 sine 2 pi 50 t minus 105 degree. Okay, and we apply here identity. Let us remember that we have this identity sine for two angle, the sine of two angle A and B can either be added or subtracted. Now the equivalent functions or trigonometric functions of this these two angle added or subtracted are this. So sine A cosine B. So if it is addition, it will be addition also. If it is subtraction, subtraction also. And cosine A sine B. So we apply it here. So we write E sub 3. So what that is 100. So what will happen? We have here A and B. So A will be 2 pi 50 t and B is 75 degree. To facilitate the discussion, let us assign omega here, which is 2 pi 50. So instead of writing 2 pi 50, we just write omega. Okay, so what will be the result? So it will be sine. So 100 will be distributed to the terms. Sine A, what is A? That is 2 pi 50 t. So that is omega t. And cosine B, cosine B is 75 degree. Since this is minus, so it will be subtraction, and cosine omega t sine 75 degree. Okay, so plus we go to this term, that is 120 again sine. Okay, that 120 will be distributed again to the terms, so that is omega t cosine 105 degree. So minus, you have cosine omega t and sine 105 degree. Okay, so we simplify equation by getting the value for cosine 75. So if you take your calculator, just write it here. You can right away get the value. For example, of cosine 75 degree, this is equivalent to 0.259. Okay, and for your we have here sine 75 degree, this one, and this is equivalent to 0.966. And also we take the value also of cosine 105 degree, and this is equivalent to negative 0.259. Okay, and the other one is sine 105 degree. So the value of this by using your calculator, that will be 0.966. So you substitute these values of this function to the equations. So and what will happen, you will get a result. Okay, so if you take these values, okay, and you get the you separate the cosine from sine, so we will have this result, 25.9 sine omega t. Okay, for this term, for E sub 1, 25.9 sine omega t minus 96.6 cosine omega t. Okay, and plus, okay, so we group this one, so plus for this term, the result will be that will be negative 31.08 sine omega t. Okay, and also minus 115.92. Okay, cosine omega t. So that this will be the value if you substitute these values of cosine to the equation E sub 3. Now, so we will have the grouping for sine, so 25.9 sine omega t, and this one, so you'll just add 25.9 added to negative 31.08, so it will give us negative 5.18 sine omega t. And for the cosine part, we have negative 212.52 cosine omega t. Okay, so you group the sine and cosine, you add, and then this will be the result. So therefore, we have E3, based on what we have studied, the general concept in solving two AC voltage sources in a function of t. So what we did is we take this one, okay, and have it, since we know that it will be represented by a right triangle, so therefore to get the hypotenuse So we take this one and have it squared and add, and then take the square root. Okay, so we have 5.18 squared plus 212.52 squared. So you take the square root, that will be the C. Okay, that will be the C equivalent, and then sine. Okay, so omega t plus theta. So what will be your theta? So theta is the inverse tangent. Okay, since this is represented in a right triangle, okay, so that will be your opposite side is negative 212.52, and your adjacent side is negative 5.18. Okay, so you get your calculator and you can solve for the result of this tangent. So what will be the result? Your e sub 3 is equals to, okay, taking your calculator, you 5.18 squared plus 212.52 squared, then the square root of that, you press your calculator, the result will be 212.58. Okay, and you copy sine, again omega t, omega is again 2 pi 50 plus the inverse tangent of this one, calculator again, it will give you 86.60 degree. Okay, so this will be the resultant electromotive force. So it is expressed in T. Okay, so this will be your answer for letter A. Now, after you have find out, after getting the resultant EMF, we go now to letter B. So we are asked to get the angle between E sub 1 and E sub 3. So we are actually getting the theta between E sub 1 and E sub 3. Okay, so it is just simply as the theta between E sub 1 and E sub 3 is actually the theta and the angle which was in your E sub 3. So what was that? So that was negative 75 or 75. Okay, so it will be 86.60 degree, which is the angle of E sub 3, this one, okay, minus 75 degree, or plus negative 75 degree or negative 75 degree. Okay, so what will be the result? This is 11.6 degree. So this will be the angle between E sub 1 and E sub 3. You just simply add the angle.